technical mathematics lesson. Today we'll be focusing on analytical geometry. By the way, my name is Mr. Posa. Now, before I can take you through this topic, I just want to advise you, grade 12s, that make sure that you do have examination guideline for technical mathematics, because it's going to help you in every topic that is there in technical mathematics. It outlines the important information that you need to understand before you go and write your exams. So make sure that you do have that document, and then you can get it from the DBE website, Technical Mathematics Examination Guideline, right? Now let's proceed. Let me just take you through the today's topic. All right, thank you very much. As you can see on the screen, that today we'll be dealing with analytical geometry. Now, before we can talk about the topic that we will be doing today, the subtopic, I just want to show you that this analytical geometry, it takes or it contributes 25 plus or minus 3 marks for paper 2. So it's a topic that you'll find it in paper 2 for technical mathematics. So it's very important topic that you should revise thoroughly before you can go and write your trial exam or your final examination. All right, now under analytical geometry, we have subtopic that we need to look into. The first one, we have linear analytical geometry. The second one, we have circle analytical geometry. And the last one is ellipse, right? All those topics, they fall under analytical geometry. But today's lesson is going to focus only on this one of linear analytical geometry. And the other subtopics, they will be done on the next lesson. So let me just take you through this one of linear analytical geometry. All right. Now, the introduction, what we have under analytical geometry, we'll be studying what? The distance formula. We'll be using the distance formula for this one, as you can see on the screen. That is the distance formula. So when we have to calculate a distance having 2 points, and then they ask you to calculate the distance, that is the formula that you're going to use. And then we have what? The midpoint formula. Let's see. That is the distance, the midpoint formula that we have. And then for you to be able to calculate the midpoint formula, you should have what? You should have 2 points so that you can be able to calculate what? To calculate the midpoint formula. Then we have what? We have the gradient formula. Also the gradient formula, you also need to have what? 2 points in order for you to calculate the gradient. Equals to the gradient of that particular line, right? Then we have what? The perpendicular line. It shows here that AB is perpendicular to CD. Then we are going to use what? The gradient of AB multiplied by the gradient of CD equals to what? -1. That is the product. Then we have what? The parallel lines. The parallel lines. So what you have to know about the parallel line is that a gradient of a line AB equals to the gradient of line CD, right? That is what? The parallel line. So all these formula, you will find them on the formula sheet. You don't have to memorize them. So there is no need for us. But what is important is that you need to know when to use a formula. For instance, if they ask you to calculate the distance, you must know the formula for distance. If they ask you to calculate the gradient, you must be able to know which formula to use to calculate the gradient. So all these formula, you will find them on the formula sheet during the exam. All right, let me take you through. Now let us have the one example from the exam question. All right. This is the exam type of question that you might get. Now let us study the this is to 4, point B is 2:2, and point C is -6 is to -2 in the Cartesian plane. The angle of inclination of BC is theta, right? Then let us have a question or a possible question that you might get on this problem. Then the first question says, determine the gradient of a point. Determine the gradient of line AB. Determine the gradient of a line AB. So you just have to go and look for the formula to calculate the gradient, right? Now let's see on how do we determine the gradient of line AB. First, we are going to write what? The formula for gradient, right? That says the gradient of AB equals to delta y over delta x, which is ya minus yb and xa over xb. Now, I just want to show you something here, which is very important. Make sure that if you start with ya minus yb, you should also start with xa minus xb. Because once you can start with xb here, whereas on the numerator you have started with ya, then your answer is not going to be correct, right? Make sure whatever, you can also start with yb minus ya, but whatever you have started with on the numerator, you must also start with here at the denominator for x, right? I hope I make sense. Then let's see. The second step, what you do, you are going to substitute your values. For instance, we have ya, so you're going to look for the value of y on this point A, which is 4, and then -2 divided by -6 minus 2. And you'll have your answer there. So our gradient for that line of AB is -1/4. That is the gradient, right? It's very simple to calculate the gradient. You just have to know the formula and then make sure that you substitute correctly and press your calculator. Then you get what? You'll get your gradient. Let's see the next question. Number 2 says, determine the coordinate of the midpoint of AC. Where is AC? This is the AC. This is AC. This is AC, meaning we have point D there as a midpoint, right? So we have to calculate the coordinates of that. Now let's see on how do we go about it, the solution. Now first we have to write the formula for midpoint. As you can see on the screen, we're having the formula for midpoint there, which says midpoint of AC equals to what? XA plus XB over 2 is to YA plus YB over 2. Please, sometimes learners do make a mistake of writing negative in between here, right? Make sure that you understand and take or copy the formula from the answer sheet correctly, all right? And thereafter, we are going to substitute now. For XA, you know, you go to the point A, you take the X value there, which is -6, then you just substitute them on the formula. Thereafter, you press your calculator, then the value of X is -6 and the value of Y is equals to 1. There you've got what? The coordinates of D, right? Now let's proceed. The questions still continue. Now, let's have another question. Number 3, determine the equation of a straight line. Determine the equation of a straight line dB in form of y equals to mx plus c. Determine the equation of a straight line BD, where's BD? BD. Remember, we have determined what? We have determined the coordinate of D there. Determine the equation of straight line DB in form of y equals to mx plus c. Now, before we can start answering this question, remember, if you have to calculate the equation of a straight line, you only need 2 things. You only need 2 things. One, you need the gradient of that particular line. You have to answer on the scenario, get the gradient and the point. That you're going to use is point B. Let's use point B. Then you substitute. Then after you have substitute, then we have the value of the gradient. Our gradient is 1/8, right? And then you write the formula for equation of the standard equation for straight line. Then you substitute the value of y. You substitute what? The gradient and the value of x. Then you have what? You have the equation of that particular line, all right? Then proceed. The question is still continue. Let's have another question. Determine the distance of BC. Determine the distance of BC. This is the point B, this is the point C. We are now looking for what? The distance now. So you just have to go to the formula sheet and take what? Take the distance formula, then you just substitute. And then let's see the solution. All right, we are looking for the distance of BC. So you say BC equals to square root of XB minus XC all squared plus YB minus YC all squared, right? And then next step, you just put your values, and then the third step, then you simplify it. Then we have 64 plus 16, then it gives us the square root of what? 80. Then when you press your calculator, you'll get 4 square root of 5. Then that is our distance. Very simple. Now, question 5, we have what? It says determine the size of theta. Where is our theta? Here is our theta. So we need to determine that angle there, that angle theta there. Then now, how do we determine that? Let's see on how do we determine that. First, we are going to write tan theta equals to the gradient of BC. Meaning, in order for you to determine what the angle of inclination or this angle here, theta, then we need to know the what? We need to know the gradient of line BC, right? Then here we have the gradient. Then we then substitute the values that we see. Then our gradient, it will be what? Our gradient is 1/2, and therefore we are going to divide with tan both sides so that we can have what? Theta equals to 26,565 degrees, right? You just press your calculator, you say shift tan 1/2 . Now let's proceed. Now we have example 2, exam type question, and then let's see what we have. The diagram below, let's see the diagram. All right, here's the diagram. The diagram below is a parallelogram with vertices. A is -2:2, B -4:1, C 2:0, and point D is x:y, right? Then alpha is the angle which AB forms with the x-axis. Then M is 0:1 is the midpoint of what? Of line AC. Of line AC. You can see that we have that midpoint here. Midpoint of AC is this M, which is 0:1. Now let's see the question that we might get. The first question says determine the gradient of AB. Where is AB? Here is AB. Now we need to determine what? The gradient. You need to determine the gradient. So you just have to go and take your formula for gradient. Then you will be able to calculate the gradient of that line. Now let's see on how do we go about it. You first write your formula for gradient. Now let me emphasize this point again. Remember, if you have started with YA, you must also start with XA here, right? And the next step, we then put our values and you just press your calculator, then you'll have your gradient as 3/2. That is the gradient of that particular line, right? The next question, determine the equation of DC in the form of y equals to mx plus c. It's supposed to be in the form of y equals to mx plus c. Now let us see the equation of which line? DC. Let's see, where is DC? All right, here's the line DC. Here's the line DC. Now we need to determine what? The equation of that line. Now remember earlier on what I did say about the equation. What do you need? in order to be able to calculate the equation of DC. You need the gradient, you also need a point. And if you don't have a gradient, and then surely you must have 2 points that will help you to determine or to calculate the gradient, right? Now let's see what we have in this question. Now, since the DC, the gradient of DC equals to the gradient of AB, which is 3/2. Why? Now, if we can check on this line here, we have point C there is given, which is 2/, is 2:0, sorry, is 2:0. Now, point D, we don't have coordinates, right? Meaning it's not possible for us to calculate the gradient of this line. But now, where will we get the gradient? Now, since we have what? We have parallelogram, and then we know from the properties of parallelogram that the opposite side of parallelogram, they are parallel, right? Now look at here, they say AB is parallel to DC, which is parallelogram, meaning two parallel lines, they are equal in terms of what? Gradient. Meaning the gradient of this line AB is equals to the gradient of DC. Why? Because they are parallel, because we are talking about what? Parallelogram. So you should know that the opposite side of a parallelogram, they are parallel, right? The opposite side of parallelogram, they are parallel, right? Then hence we indicated that gradient of DC equals to the gradient of AB, right? Which is 3/2. Then the point that we have to use. Now we are going to take this point C here, right? We are going to use this point C here, right? Because remember I said we need gradient and a point. Now we are having the gradient, we are also having what? A point. Let me just remove this. All right. All right, gradient and a point. Now we can be able to calculate the equation now. Then standard equation for straight line here. And therefore, the next step, the value of y, it's 0. Here it's 0. At point C, it's 0. Then our gradient is 3/2. The x value there is what? It's 2. Then you just put them, and then from there you are going to simplify it. Then we're having what? Our equation now. Our equation is y equals to 3/2x minus 3, right? That is that. Now we still have another question. And let's see what type of question we'll get. All right. Now the number 3 says determine the size of theta and round off to 2 decimal place. Which theta is that? Here is theta. We have to determine this angle here. We have to calculate this angle here. But earlier on, remember we had a question where we have to calculate angle theta, right? And I also indicated that for you to be able to calculate that angle there, what is important is the gradient of that line. Okay? So in this case, we are going to have this gradient. We have to know the gradient of this line AB, right? Now let's see how do we calculate that. Let's see how do we calculate that. First, you are going to start with your formula that you're going to use, which is tan theta equals to the gradient of which line? AB, right? Then let's proceed. Remember, we have already determined the gradient of that line AB, which is 3 over 2, okay? Which is 3 over 2. Now let's see. Thereafter, you're going to press your calculator and say shift tan 3 over 2 equals to, then you will get what? 56,31 degrees, right? Because the instruction, it was saying round off to 2 decimal places. Please, right? You must always obey that instruction. So every time when you receive a question paper, first you have to read your instructions, and then what is important from those instructions, you must look for this, where they say or where they indicate how many digital number or how many decimal number you should write after comma, right? Now in this case, it indicated that we should write 2 decimal places, right? That means after comma you must have 2 values, right? Now let's see the next question. Determine the coordinates of point D. Determine the coordinate of point D. Where is point D? Here is our point D. We don't have the coordinates now. Now, we are going to learn on how do we determine those coordinates, right? Let's see what we have. Now, before we can start substituting, I just want to explain something. Since we know that this is what is the parallelogram, now we need to understand the parallelogram in terms of its diagonals, right? I have just indicated that. Let me just remove this so that you can be able to see which line. All right, let me just erase and repeat it. Now, in order for us to determine this point D, the coordinates of point D, we are going to utilize what? Utilize the diagonals of parallelogram, right? If we can check, the midpoint of AC is M, right? Then should we must have what? Another diagonal line from point B that will pass through this point M until you reach this point D here, right? You remember one of the properties of parallelogram, it says diagonals of parallelogram bisect each other, right? Meaning the midpoint of BD is this point M. The same with what? The midpoint of AC is what? Is this point M. Meaning these two lines, they share what? The midpoint. And that midpoint is M, right? And we have the coordinates of M, right? Now, from our solution, we are going to say the midpoint of DB equals to what? Equals to XB plus XD over 2, right? Then we also have to say the midpoint of BD equals to YB plus YD over 2, right? So we are going to separate them. You start with the X, the midpoint of the X, and the midpoint of Y's, right? The next step, what you do now, because I said that the midpoint of is 0, This is the midpoint, right? It's 0 there. Then xb, we have what? -4. You can see xb, the value of x there is -4. That is -4 plus xd. Where is xd? Is xd is what we are looking for, right? We are in need of that value of x. Now, here we have midpoint of db for y. So when you go to that point M, what is the value of y? Is equals to 1. And then here is our 1 equals to what? YB. Our value for y at this point is -1. Then you just put -1 there plus yd. Remember, we are also looking for what? The value of y on point D, and then divide by 2. Then step number 2, we're going to cross multiply. Then if you cross multiply on this one, so 2 multiplied by 0 is going to be 0 equals to -4 plus xd. Then here, you're also going to cross multiply. It's 2 times 1. You have what? Equals to 2 equals to -1 plus yd, right? And therefore, you are going to transpose now, because remember, we are in this case, we want to have the x value for d. We also want to have the y value for point D. All right. Now we have determined the x value for D, which is equals to 4. It is very important question. One should know on how to go about it, right? Let me just move this. I point of D, right? Now, then you will have what? You will have the activity based on what we have done since we have started this lesson. So you can just take this question and try to answer them. And then you should also have what? Make sure that you have your formula sheet so that you're going to refer to it. So if, for instance, if you want to calculate the length of whatever the line, you just go and look to take the distance formula. If we have to calculate the gradient of line CD, you just go to take the gradient formula there, right? So this is the message for you for today's lesson, that says study like there's no tomorrow, because if you keep putting off your studies for tomorrow, you will probably be late. So please, every chance you get, sit down and study. Thank you very much.